In the next few lessons, we will be working with piecewise functions, and we're going to start off with interpreting functions. So we get basically what interpreting from piecewise functions is you're looking at a graph and you're describing what's happening. A piecewise function is actually what we see is you have like a constant function, a linear, another constant. So we're looking at the different types of functions that are combined together. So we're looking at, for this example, what's the cat doing now? So based off of this graph, slide it up a little bit. So based off of this graph here, at number 1, we notice that the height is 1, 2, 3, 4, 5, 6. So that is 6 feet. So the cat is at 6 feet at this point right here. And so it's remaining constant for the time in seconds. So this would be 1, 2 seconds. So you're looking at the cat is just kind of perched somewhere. So he's maybe sitting on top of a dresser. So number 1 we'll say sitting on top of a dresser. And then you notice from this, we're looking at this line here. And so what's happened to the height is the height went from 6 feet down to 0 feet. So pretty much what's probably happening there is because there's such a decrease in such a short, in like 1 second, the cat more than likely is jumped down. So that we're going to say for number 2, he jumps down. On the line for number 3, again, it's constant there. So for the next 3 seconds, he's just on the ground. We'll say on the ground, on the floor. And then, as you notice in the next 1 second, his height increases to 2 feet. So he jumps up. Maybe on a chair. And then for the part 5 where it remains the same, he's just sitting on the chair. So one of the things we'll look at is, and we're going to do gradually, is we're going to actually get into a full story about what is happening throughout a graph. Okay, so this is another type of piecewise function. So we have all horizontal lines. One of the things that you notice here is in order for it to be a function, we have an open circle and a closed circle. We cannot have 2 closed circles in the same vertical line. So I'm going to just write that down. Cannot have 2 closed circles in the same vertical line. If we do, then it's not a function, and we're looking at these being functions. So within a vertical line, you have an open and a closed. So at the closed circle, the point's included. At the open circle, it is not included. Okay, so basically what we're going to do is we're just going to kind of interpret what this graph is showing us. So we get weight in ounces on the x-axis, the cost in cents on the y-axis. So we're looking to figure out the cost of postage for an object weighing, a letter weighing 2 ounces. So if we go to 2, we see there's a closed circle at 2 for here, but there's an open circle. We're going to be working with the one that's closed, and that's reading at 48 cents. So that would be 48 cents. So for 2.2, 2.2 falls between 2 and 3. 2.2 is falling on, so this is between that 2.2 and 3, but 2.2 is falling on that line, so that's representing 50 cents. For 3 ounces, we go and we find that 3 ounces would cost 50 cents. 3.5 ounces, we follow up to find where 3.5 lands, that's at 52 cents. And lastly, at 4 ounces, that cost would be 52 cents. So if it cost Trina 54 cents to mail her letter, how many ounces did her letter weigh? So 54 cents, if you're looking at 54 cents, is looking at this interval right here. So that means her letter could be, would have to be more than 4 ounces, but less than or equal to 5 ounces. So the cost per letter would be, or the measurement of her letter, the weight of her letter would be more than 4 ounces. Move that over. But less than or equal to 5 ounces. Okay. I promise you that I already had this example before today. The following graph shows the depth of snowfall after midnight. Describe the snow activity. Okay, so we're going to go ahead and we're looking at the time, hours past midnight. So right here is 0. The 0 is representing midnight. So that would be midnight, 1 a.m., 2 a.m., 3 a.m., etc. And then these are numbered by 2s. It's kind of hard to see, but this is 2, 4, 6, 8, and it keeps up going by 2s. And I'm assuming that when we're talking about 2, it didn't really say here, but we're going to assume it's talking about inches. Okay, so to interpret this, notice there's nothing there for you other than the graph. So you're going to describe the snowfall activity over time. So when we look at this, we look at the first part, we're going from midnight to 4 a.m. So you're talking about this piece of the graph because this remains pretty constant. So from midnight to 4 a.m., there is a steady snowfall producing 6 inches. So from 0 inches to 6 inches. So it took those 4 hours to produce 6 inches of snow. And that's, if it's 6 inches of snow in 4 hours, that's at a rate of 1.5 inches per hour. So that's our first piece. The next piece, you notice that line is a little bit steeper. So from 4 a.m. up to 7 a.m., we're looking at how much is being produced. So it went from 6 to 8, 10, 12, 15 inches. So from 6 to 15 inches, so that would be a total of 9 inches. So that means from 4 a.m. to 7 a.m., the snow is much heavier, and we know that because of it was snowing heavier because the line's steeper, and it actually produced 9 inches in those 3 hours. So in 9 inches in 3 hours, we would be producing 3 inches per hour. And then the last piece here, if you notice, this line's not quite as steep. So from 7 a.m. to 9 a.m., it went from 15 to 19, it looks like, maybe. And that would be 4 inches in those 2 hours. So it actually, the amount of snow that was falling decreased because it's now at a rate of 2 inches per hour. It's faster than it was originally, so that line's a little bit steeper than what you saw here. So that's describing what the depth of the snowfall after midnight. Okay, on this one, we have a journey to the bus stop. So every morning, Tom walks a straight road from his home to a bus stop, a distance of 160 meters. The graph shows his journey in one particular day. So we're going to describe a situation that represents Tom's journey to the bus stop. So it's kind of like you're telling a story. You're going to tell a story about the graph. Okay, so when we look at the first part of the graph right here, it's a time in seconds, and this is the distance from his home in meters. So pretty much what we see here is for like the first, 50 seconds, Tom is walking to the bus stop, and he's traveling 100 meters on his way to the bus stop. Then notice that his distance decreases, so perhaps he forgot something. So maybe he's not going all the way back home because it doesn't go back to 0. So he travels back what? 20, 40, 60 meters. So maybe he forgot his lunch pail or dropped his lunch pail on the way. So maybe at the top of the driveway he drops his lunch pail or something. So he's headed back to pick that up. So then once he gets that, he then proceeds to the bus stop at a much faster rate. So maybe I would say that for this right here, he's more than likely jogging, because he's going, what is it? He's traveling, what, 20 meters there? No, 20 seconds, he's traveling 20, 40, 60 meters. So that's 3 meters per second. So I would say that he was walking here, and then he probably ended up jogging back. And then notice this is much steeper than his original rate. So he's probably running to the bus stop at this point because he had to backtrack. And so if we look at, he's traveling 20, 40, 60, 80, 100, 120 meters. And it's taking him 10, 20, 30 seconds to travel those 120 meters. So he's actually running he's running to the bus stop at like 4 meters per second. And then once he gets to once he gets almost to the bus, once he gets to that bus stop, he's actually right here. He's not traveling any more distance. He's just sitting there waiting for the bus to arrive, for him to get on the bus. So you kind of put that together and you put it into words. So I've kind of summarized what we just talked about here. So the first 50 seconds of Tom's walk to the bus stop, he travels 100 meters at a rate of 2 meters per second. He realizes he dropped his lunch bag at the end of the driveway, so he jogs back 60 meters in 20 seconds, a rate of 3 meters per second. He then proceeds to the bus stop running at a faster rate than he was previously walking and jogging. It took him 30 seconds to reach the bus stop 120 meters from his driveway, a rate of 4 meters per second. Tom waits 20 seconds to get on the bus. Okay, and then the last example, we have cost of t-shirts. So we have the number of shirts and then the price per shirt. So we have a graph that represents that. Now, if you notice right here, there's not an open or closed circle, because if you're getting the cost of the number of shirts, 0 shirts is going to cost $0. So you can't really have a price of 0 shirts. So it's from 1 to 10 right here, or 1 to actually 20. It goes up to 20. So that's going from 1 to 20. The price per shirt would be $20. So if purchasing anywhere from 1 to 20 shirts, the price would be $20. So to describe the cost of the t-shirts, we're looking at from 1 to 20. For 1 to 20 shirts, the cost is $20. $21, so this next one, we're not including 20, so it goes from 21 to 40 shirts. Cost $15 per shirt, and that's per shirt. And the next interval goes from 41 to 80. So 41 to 80 shirts are purchased. That cost is going to be $10 per shirt. And then if we look at our last interval here, it's from 81 or more. I put 2, but we need to put or more. So 81 or more shirts cost $5 per shirt. So that's interpreting that graph. He wants to know how much would 80 shirts cost. So if there was 80 shirts is not included in this interval because that's open circle. 80 shirts is included here, and they would be $10 per shirt. So 80 shirts would cost $10 each. For a total cost of $800. Okay, so that kind of concludes what we need to see as far as what interpreting those graphs are. There are a couple of them that I want to talk about from the assignment. So this is an example. This is your first problem for the assignment. But the problem is understanding what the numbers are on the grid. So I want to make sure that you guys are clearly understanding that. But it does give you the scenario of what's happening up here. So make sure that you read your scenario. And when we look at it, we got to look at what does each of these dots represent. So when you're looking at this right here, these are actually the time is actually in minutes, so that'll help for you to know the unit. So we're going to be in minutes. And this is representing every 2 seconds. So this first dot right here is 2 minutes, I'm sorry. Then 4 minutes. So you have these little intervals here. 2, 4, 6, 8, 10, etc. And then so that's for your x-axis. On the y-axis, it is also numbered by 2s. You see that little 2? It's kind of inside, but this little dot here is 2, and this would be the number of blocks. So that does help to know that. So we're talking about the number of blocks as far as she's out taking a walk, I guess, or a jog or something like that. I can't remember what it was, but she's going a certain number of blocks. So that would be 2 blocks, 4 blocks, 6 blocks, 8 blocks. So this point right here is representing in 4 minutes she's traveled 8 blocks. So you're going to actually make a story that goes along with that, an interpretation of this, of Mrs. Smith taking her walk throughout the city. Or maybe a run. You'll have to figure that out. Okay, and then the last thing that I want to talk about is for the question number 3. Question number 3 gives you a situation where in a parking lot in Fort Lauderdale, they charge $1.25 for the first hour, 75 cents for each additional hour or fraction of an hour. There's going to be a table that you're going to complete, and then you're going to determine which graph appropriately demonstrates the situation. And the graphs are going to be on the next page. They'll be on page 2 of the assignment. And then there's actually 5 of the graphs, and I picked one here to talk about. But you're going to, for the 4 graphs you don't choose, you're going to explain why they're not correct. So you're not just going to circle and say, well, this is the graph that it represents, because the ones you don't pick, you're explaining why they're not correct. Okay, so just to kind of help you guys out with a little bit on the scale part of it. So the x-axis, we have the time in hours. And on the y-axis, we're talking about the cost. So that's already labeled for us. So I think what's hard to interpret this is actually what the scale is here. So for the number of hours are by ones. So this is actually at 0 right here. Not to have these decimals confusing you around here. But you're starting at 0 hours. Then there's 1 hour, 2 hours, 3 hours, etc. And then the scale that you're looking at here, and I gotta get my pen a whole lot smaller than that. When you're looking at the scale going up here, these are represented, this is as a scale of, on the y-axis, it's every 25 cents. So each dot on the y-axis represents 25 cents. Okay, so this first dot right here, that's 25 cents. Then the next one would be 50. Then we would have 75 and $1. And then this one right here, where that dot is falling, would be $1.25. So they're going up by 25. So that would be 150, 275, whoops, 150, 175, and then $2 right there. And so it's going up by 25 cents for each mark, or each dot, or each tick mark there. Okay, so once we got the scale figured out and you understand how the scale's working, we would look to see if this was an appropriate graph. And one of the things you got to look at is when you're talking about the cost. Once you make your table, you'll be able to look at your table, but the cost is not going to change. The amount for the fractional amounts are going to be rounded up. So it's not going to be like there's a cost of, for example, if you're starting off with, for the first hour, $1.25, and then so for $1.25 for the first hour, and then 75 cents for each additional hour, or fraction of an hour. So like if you have a half an hour, it's still going to cost 75 cents. So for the first hour, it's $1.25, and then for the second hour, it would be 75 cents more, which would be $2, etc. Okay, so when you look at that, though, the fraction of the hours are not included based off of this. So this is not a good representation, because the cost for a fractional amount of parking is rounded up, so the lines would be horizontal. So if you park for 15 minutes, you'd round up to the hour, and you would pay for the entire hour. So that is your graph A, and that is not correct, but I just want to make sure you guys understood the scale. So you have just a few questions to answer. Make sure you give me a good interpretation for number 1, and give me good explanations for B, C, D, and E. We've already talked about A, but you would actually explain it. You would have to put it into words.